Hello, and welcome to the Variables and Procedures module in our Introduction to VBA for ArcMap course. My name is Eric Pimpler, and I will be presenting this module. This module will cover the principles of variables, procedures, and functions in the VBA language. This module is broken down into two main components covering variables in the first section and procedures and functions in the second section. We'll first introduce you to the concept of variables. Initially, we'll learn what variables are, how they can be declared, and what data types they can hold. Next, we'll cover the issues of scope and lifetime as they relate to variables. After a thorough introduction to variables, we'll proceed to procedures and functions. In this section, we'll cover the basic concepts of procedures and functions, learn their syntax, understand the differences between the two, and cover the types of arguments each can accept. Let's start with a basic programming question. What are variables? We can think of variables as empty boxes in a computer's memory that can be used to store values. Each variable in a program is given a name that it can be referred to in other areas of our code. VBA requires that variables begin with a letter and be no more than 255 characters in length. However, in practice you want to keep variable names as short as possible, but still meaningful. Variable names can't contain characters such as periods, exclamation points, mathematical operators, or comparison operators. In addition, they cannot contain spaces. They can contain underscores or numbers as long as the variable name begins with a letter. Finally, variable names must be unique to the scope in which they are operating. In this slide, you will see some examples of acceptable and unacceptable variable names based on the VBA rules that we set forth in the previous slide. Here, we see a diagrammatic view of the concept of variables as empty boxes capable of containing data. In VBA, the dim keyword is used to declare a variable. Here the statement dim my dog as string is declaring a variable named my dog, and that this particular variable can contain only string data. At this point we have only declared the variable, and thus we can think of my dog as an empty box waiting to receive data. The statement my dog equals Sparky is a VBA statement that can be used to populate the my dog variable with data. The string Sparky is now contained within the variable my dog. In other words, the previously empty box my dog now contains data. Once we've declared a variable and assigned a value to a variable, we are ready to put it to use. In the statement messagebox my dog, we are using a built-in VBA function to display the contents of the my dog variable in a message box to the user. Obviously, this is a simplistic example, but hopefully you now understand the basic concept. In VBA, variables can be declared explicitly or implicitly. Explicit declaration of a variable requires that you explicitly declare a variable using the dim, public, or private keywords, and is the preferred method for a number of reasons. Explicit declaration makes your code easier to read and maintain. It also helps VBA catch data typing errors at design or compile time rather than runtime, and it is more efficient in terms of memory usage and processing. Implicit declaration occurs when you assign a value to a variable without first declaring its name and type with the dim, public, or private keywords. VBA automatically assigns all implicit variables to the variant data type, which can contain any type of data. Variant variables take up more memory than other variables and execute somewhat more efficiently. In this slide, we see a number of examples showing the proper way to explicitly declare variables. Note that each variable is declared with either the dim, public, or private keyword before a value is assigned to it. There are some cases where you may want to implicitly declare a variable. In some cases, a function may return a variant variable, or you may simply not know what type of data the variable will have to store. In these cases, it will be necessary to either declare a variable to be of a variant data type, or simply allow the variable to be implicitly declared. Here are some examples of implicitly declared variables. VBA supports a number of data types that can be assigned to variables. In this slide, you will see the most commonly used variables in VBA, along with simple examples of the data that these variables can hold. In this slide, you will see more examples of the types of data that can be assigned to a variable. Take special note of the object variable type. We will explore these in greater detail later in the course. For now, you should understand that these types of variables store references to objects rather than primitive types of data such as strings, numbers, dates, or booleans. This is important because you will work extensively with object variables when working with ArcObjects. ArcObjects is a large set of programming libraries that are used to generate objects that are used to perform GIS functionality. You will work with these ArcObjects through assignment to object variables in VBA. At this point, we're going to take a look at the variable types that VBA supports in greater detail. The first data type we'll examine is the Boolean data type. Boolean variables can be set to one of two values, true or false. You'll see an example of how to declare and use Boolean variables in this slide. Date variables are relatively complex data types that can handle date values. You will frequently use built-in VBA functions such as now and date to obtain and manipulate date values, although date values can be assigned as literal values. There are a variety of numeric data types that are supported by VBA. The most commonly used types are double, long, and integer. The double data type can be used to hold floating point numbers and can handle both negative and positive values. Here you can see the range of numbers that can be held by the double data type. Integer data types hold integer values between minus 32,768 and 32,767. For integer values beyond this range, you can use the long data type, which holds values between negative 2.1 billion and 2.1 billion. The use of the long data type is encouraged over integers to prevent the program from breaking when dealing with numbers that are larger than expected. You will probably use the string data type more than any other type of variable in VBA. It is used to handle text values and can contain about 2 billion characters. Strings can contain letters, numbers, space, and punctuation, as well as special characters. Here you'll see some examples of the string data type. All the data types we've discussed up to this point are known as intrinsic data types. They are part of the internal structure of the VBA programming language. Object variables differ from these intrinsic data types in that they store memory addresses that reference objects. The object itself is not stored, only the reference to an address space in the computer's memory. Assigning a value to an object variable also requires a new syntax. You must use the set keyword to assign a value to an object variable. Additionally, objects typically have properties and methods. In this example, we declare an object variable, use the set keyword to assign a value to the variable, and use a property of the object. Right now, the key is to understand that you must use the set keyword to assign a value to an object variable. The variant data type is assigned by VBA to all variables whose data type isn't explicitly declared. They can hold data from most of the different types of data, including strings, numeric values, dates, and objects. The downside to using the variant data type is that they are more memory intensive than any other variable, and they don't process as efficiently because VBA is forced to convert the variable data type into its actual data type on the fly while working with the data stored in the variable. This slide simply shows a simplistic example of working with variables and takes you through the process of declaring, setting, and using a variable. To see a demonstration of variables, variables, click the link on this slide. Now that we have a basic understanding of variables, let's move on to a discussion of variable scope and lifetime. In VBA programming terms, scope can be defined as the area in VBA within which a variable can operate. Lifetime can be defined as the period in which VBA remembers the value of the variable and is tied directly to scope. VBA has a built-in garbage collector that removes a variable from memory when it is no longer referenced in the application. There are three types of scope in VBA. The first is procedure-level scope. When a variable is declared inside a procedure or function, it has procedure-level scope and can only be used within that procedure or function. Private-level variables are declared with the private keyword in the general declaration section of a code module. These variables are available to all procedures in the module that contains it, but not to procedures in other modules. Public-level variables are declared with the public keyword in a code module and are available to all procedures in all modules of the project. As we mentioned in the previous slide, variables declared within a procedure or function have procedure-level scope and are only available to the procedure that contains it. The lifetime of these variables is limited to the time in which the procedure is running. As soon as the procedure stops running, the VBA garbage collector will remove the variables and free up the memory taken by these variables. In this example, we see two procedure-level variables being declared within a procedure. These variables can only be used inside this procedure. Privately scoped variables are declared with the dim or private keywords in the general declaration section of a VBA code module. Privately scoped variables cannot be declared inside a procedure. These variables are available to all procedures within the code module, but are not available outside the code module. As long as the project containing the private variables is open, the variables remain in memory. Take a look at this example. Here, two private variables are declared in the general declaration section. Note that you can use either the dim or private keywords, as long as the variable is declared in general declarations. In this example, a procedure inside the code module is using these variables. Publicly scoped variables are also declared in the general declaration section of a VBA code module. They are declared with the public keyword. These variables are available to any procedure within any code module in the project, and the variables stay in memory for the duration of the project. A public variable can be declared within a form, standard, or class module. When declared in a standard module, these variables are also known as global variables. Static variables are a special type of variable that retain their value between calls. Their scope is the same as procedure variables, but their lifetime is that of a module-level variable. These variables are declared inside a procedure using the static keyword or in the general declaration section of a module. Click the link to view a demonstration of variable lifetime, and scope. Now we'll turn our attention to procedures and functions. Although they are similar, there are some fundamental differences between the two. Procedures are a named unit of code that contains a sequence of statements to be executed as a group. All executable code in VBA is contained within procedures and functions. Much as variables have modifiers, procedures can be typed as either public or private. In this slide, you'll see an example of a public procedure. Public procedures can be called from any code module, while private procedures can only be called by the code module containing it. In this slide, we will examine the basic syntax of a procedure. As we stated in an earlier slide, a procedure can be marked as either public or private. Use of the static modifier will mark all variables inside the procedure as static variables that retain their values between calls. The keyword sub is included with each procedure. Furthermore, each procedure must be given a name. Procedure names must be unique to the module if they are declared private, otherwise unique to their project if given the public modifier. Naming of the procedure must follow variable naming rules. Finally, each procedure can contain an argument list. An argument list is one or more variables that are passed into the procedure for use. Multiple arguments are separated by commas. A function is a series of visual basic statements enclosed by the function and end-function statements that returns a value. Like procedures, functions are designed to perform specific tasks. However, unlike procedures, functions always return a value to the code that called the function. The return value of a function can be assigned to a variable. VBA has many built-in functions including left, right, message box, and many others. In addition, you can build your own functions to accomplish specific tasks. Take a look at this example to see the VBA function left in action. The left function takes a string variable or explicit string, along with a second parameter that specifies how many characters to return. In this case, we want the function to return 6 characters, or the word Monday, from the input string. As we mentioned in the previous slide, functions always return a value to the calling code. The type of value returned is specified with the asType statement, where type is a VBA data type such as string, long, object variable, etc. In the example on this page, the function returns a double variable data type to the calling code. The return is accomplished by setting the function name equal to a value. Here, the total price function returns by setting total price equal to some value. Let's examine the syntax of a function. As with procedures, you can use the public or private keywords to control access to the function. Static indicates that all variables inside the function retain their values between calls. As with procedures, all functions must be given a name that conforms to variable naming conventions. In addition, functions may take arguments that are passed into the function to be used as variables. Finally, each function must return a value as specified with the asDataType statement, where data type is a VBA variable data type. We've touched briefly on arguments when covering procedures and functions, but let's cover these in more detail. Basically, an argument is a piece of information that you pass to a procedure or function. Both procedures and functions accept arguments, but they are not necessary in all cases. Arguments are enclosed by parentheses just after the procedure or function name. Each argument passed to the procedure or function must be given a name and data type in the format argument name as data type, where data type is a VBA variable data type. Multiple arguments are separated by commas. Arguments can be required or optional. Take a look at this example of an argument. Here we're passing in a string argument which has a variable name of state. This is a required argument and VBA will raise an error if it is not passed into the procedure or function by the calling code. As we mentioned in the previous slide, arguments can be required or optional. By default, an argument is required, but through the use of the optional keyword, you can mark an argument as optional. In addition, optional arguments must be at the end of the argument list. In this example, notice the use of the optional keyword on the last argument in the list. This effectively says that you have the choice of whether or not to pass in this argument. There is another qualifier that can be added to arguments that are passed into procedures or functions. Arguments can be passed in by val or by ref. When an argument is passed into the procedure with the by val keyword, VBA makes a copy of the variable for use inside the procedure. When an argument is passed in by ref, VBA does not make a copy of the variable. This is a very important distinction because an argument passed by ref will allow your code to make changes to the original variable. This can have unintended consequences in your code if you're unaware that the value of a variable is being changed. The rule of thumb is to always pass by reference those arguments that must be modified by the procedure, and pass by value all the others. This minimizes the risk of accidentally modifying the value of a variable passed to the procedure. Although functions and procedures are similar in many ways, they are also different in some important ways. The biggest thing to remember is that functions always return a value, while procedures never return a value. Take a look at these examples to see the difference. Click the link in this slide to see a demonstration of procedures and functions.